Good afternoon, everyone, and welcome to our live coverage of the latest mission from NASA's Kennedy Space Center. I'm Will Robinson Smith. I'll be performing our commentary for the duration of this coverage. We are broadcasting, as we always do, from the Spaceflight Now News Bureau here at KSC. It is a busy afternoon, lots to talk about, which is why we are joining you 2 hours before the planned liftoff of the rocket du jour. We are currently T-minus 1 hour, 56 minutes, 30 seconds and counting. Lots of interested folks, photographers, journalists, experts in the fields connected to the launch that we're going to see coming up in less than 2 hours as SpaceX is preparing to launch its 10th Falcon Heavy rocket to date and the fourth and final of a series of important geostationary weather observing climate modeling satellites known as the GOES-R series. The one flying today is called GOES-U. This is a joint mission between NASA and NOAA, the National Oceanic and Atmospheric Administration. GOES stands for Geostationary Operational Environment Satellites. This is, again, the fourth and final in a series of satellites that help meteorologists around the country provide increasingly better, more accurate, and more timely weather forecasts. The spacecraft also has the ability to pinpoint fires as they're starting from more than 22,000 miles above the Earth's surface and zoom in to detect a fire the size of a small barn. So lots to talk about with this spacecraft, and we've got a lot of different interviews and things to bring you information about it as we go through the next couple of hours. As you're looking at this Falcon Heavy rocket here at the heart of Launch Complex 39A, you'll notice that the side boosters, and you can see a little bit of that center core as well, all shiny and new. All three of these first stage boosters that SpaceX is using today in support of this mission are brand new, launching for the very first time. Talk a little bit more about why SpaceX is using brand new boosters on this flight. Helps to work into their model of reusability. We'll hear more from a SpaceX representative a little bit later on in the broadcast. We also noticed, though, above the three boosters there, you see that gray band just beneath the second stage, the bottom of the second stage. That band helps keep the liquid oxygen on board the Falcon Heavy second stage at the right temperature, as this is going to be a very long coast phase for this mission to send the GOES-U satellite into a geotransfer orbit. We are currently T minus 1 hour, 48 minutes, 19 seconds and counting. We do have the full team out in force today, with the exception of our friend Chuck Briggs, who's taken some well-deserved time off. But Pete Carson's with Max Q Productions will be out with us today, as well as our launch photography team of Adam Bernstein and Michael Kane. If you haven't already, be sure to hit that like button to allow more folks to find their way to our live coverage. And if you are in the Central Florida area hoping to see this launch for yourself, you may have noticed it is quite hot and steamy out there today. The weather coming into this launch opportunity is also something that has been closely tracked in the days leading up to today, launch day. And in just a couple of minutes, we're actually going to be joined by a launch weather officer from the 45th Weather Squadron to break down where we are currently with the weather outlook for launch, some of the things that the meteorologists are tracking, and what the probability of go is for an on-time liftoff at the start of the window. So we'll be back in just a couple of minutes with that live interview. So stand by, enjoy the views of the pad, and we'll be back with you with commentary momentarily. Welcome back, everyone. You're watching our live coverage of the NASA and NOAA Goes You mission. We're currently T-minus 1 hour, 39 minutes, 47 seconds and counting to liftoff of the Falcon Heavy rocket. We've been talking about the weather for this mission, not only because it's a weather observing satellite, so it kind of, falls in the nature, but also because weather may play spoiler to this, still TBD. Fortunately, though, we're joined by someone who has all the answers, at least up to this point, as the weather is still currently being tracked. Melody Lovin is a launch weather officer with the 45th Weather Squadron, has been with them for 6 years, was also a meteorologist with the National Weather Service before then. Melody, welcome to the show.
Thank you. My pleasure.
And so, obviously, the weather, important for the variety of reasons that I just mentioned. At this point in time, how are we looking as far as the probability of violation, or, put another way, the likeliness that weather will play spoiler for a 516 launch?
Well, it seems like we have a window of opportunity at the beginning of the launch window, so right around 5 o'clock. Right now, the probability of violation is 50% at the beginning, but it gets worse throughout the window. So it increases to 70%, or otherwise known as a 30% no-go at the end of the window. And that's mainly due to thunderstorm development inland, spreading some anvils across, possibly to the pad, towards the end of launch. We actually currently are no-go for the detached anvil rule. We are expecting to clear for that, hopefully within the next 10 minutes or so. But we may be in and out of it for a little while as far as go and no-go conditions.
And your colleague, Brian Cizik, was talking yesterday during the pre-launch weather briefing about some of the things that you and the team are tracking. How much of those are still in play, if not all of them at this point?
They are all still in play because we are still expecting thunderstorms. But at this point in time, it seems like the sea breeze has marched inland just enough where our primary concerns are going to be anything having to do with anvil, so detached anvil or attached anvil. We can't rule out those other thunderstorm probabilities, though, for surface electric field mill rule, lightning rule, cumulus cloud rule, still very much in play, but anvil, especially since we're currently no-go for detached anvil, that's going to be our primary player.
And for those of us who live in Central Florida, it's June. We're used to, afternoon thunderstorms just being a part of the norm. Coming into this opportunity, looking at the T-3, T-2, T-1, or L-1, the launch weather forecast stayed pretty static.
Yes.
Is that pretty much to be expected for a launch this time of year? Does it seem, out of the ordinary?
I would say it's certainly not out of the ordinary. 5 p.m. to 7 p.m. In late June, we all know we're going to getting thunderstorms. Exactly where is the key, though. So with this setup, we were expecting pretty solid westerly flow. We've actually, it hasn't quite materialized, it's become weaker than we were expecting. So because of that, we have more of an opportunity, which you've seen with our trending forecast today, 50% going to 70 instead of just a solid 70. But I know my colleagues and I, when we saw the timing of this launch, that it would be 5 to 7 p.m. in late June, we were a little worried.
A little skeptical.
A little skeptical.
And so, when you're trying to thread the weather needle, so to speak, when you're a launch provider like SpaceX or ULA, talk to us about how that process of sort of narrowing down within a launch window, feeling hasn't started, what goes into sort of keying into a key time. Obviously once a violation clears, that certainly helps.
Yes.
But how do you kind of narrow beyond that?
It's very hard. It's very hard. The hardest part about our jobs is providing the best recommendation for the T0, especially in a weather scenario like this where we could be no-go at the beginning, go in the middle, no-go at the end. So it's all about just what the current conditions are and how we expect the boundaries to collide and form and where those openings could be. It's very much nowcasting. We've got a lot of great high-res models to help us, but when it comes down to it, when we're on console, we really just have to look at how the evolution is currently and just know with instinct what will happen. So it's a challenge, very much so. 3 days prior, forecasting is an entirely different world than day of launch.
Of course, and I'd be remiss if I didn't ask you, since we're launching a weather satellite, hopefully sometime in the next 2 hours between 516 and 716, how much of an impact does a satellite like Goes You and the rest of the GOES-R series matter for meteorologists like yourself?
It matters. It's satellite, Goes You plus radar, it's the bread and butter of everything that we do, but especially the latest GOES series. I remember when GOES-R came out, and I was still working for the National Weather Service at that point in time. And it finally started flowing to our workstations, and it was like going from black and white TV to HD color. Like, it was incredible. There were so many things that we learned in school in textbooks that it was just more of a theory, and now we could actually see. And it was just amazing, going from, you know, getting a satellite image update every 15 to 30 minutes to every 5 minutes, sometimes every 1 minute. It changes everything, and it certainly has.
Well, hopefully the next change can come in the next hour and a half or so.
Fingers crossed.
Melody, thank you so much for joining us.
Thank
Really
you.
appreciate it. And of course, we're going to have much more live coverage continuing on for the next hour and a half, right up to that point of T0, and then, you know, tracking this satellite till it deploys. So keep it right here to Spaceflight Now. Lots more coverage coming up. We'll be right back with more commentary, and until then, enjoy some live views of the pad. Our thanks again to Launch Weather Officer Melody Levin for making us all a little bit smarter about launch weather and the odds of moving forward with the GoZoo launch coming up now less than an hour and a half away. We are currently T minus 1 hour, 25 minutes, 48 seconds and counting. Certainly want to thank the more than 3,900 of you that are joining with us live this afternoon. If you haven't already, it would be very much appreciated if you could hit that like button. It allows more folks to find their way into our live coverage as we continue to roll along here. Also want to thank some of our channel members for kicking us off with some generosity here. To Callistia Lee and Mark Otto for gifting 10 Spaceflight Now memberships apiece. Same to Mitchell Wilbur, also with 10 memberships. And to Ray M, gifting a Spaceflight Now membership. Appreciate that from all of you. And to our newest 31 channel members, welcome aboard. We're glad to have you with us. Be sure to thank Callistia, Mark, Ray, and Mitchell in the live chat if you haven't already. Channel membership comes with a number of perks, including discounts at our online shop.spaceflightnow.com, access to member-only videos here on YouTube, and the ability to watch all the moments of liftoff from here at the Cape in 4K. Also, if you'd like to be a part of our show and you have a comment or question that is appropriate to be read on our broadcast, you could use the YouTube Super Chat feature, like one of our wonderful channel members, Roskin. $5 Super Chat, who apparently was gifted channel membership by Ray M. Before we move along any further, certainly want to thank our wonderful moderators in the live chat. See, Callistia Lee is working hard, holding it down. Keep our eyes out. Oh, I see AstroGen is with us this afternoon. We'll look for Astro Joe and Stephanie B, Rusty Shackelford as well. If you are just joining us and happen to miss our live interview with Launch Weather Officer Melody Levin, she mentioned that the team with the 45th Weather Squadron tracking a detached anvil cloud, which were the launch to be happening now, as in if the rocket were fueled and they were preparing to lift off, the weather would be no-go because of that detached cloud and the fact that it still carries the charge with it from the thunderstorm that it came from. So as you're wrapping up that interview, that impact had not cleared, but we'll continue to keep our eyes open for any further updates from the 45th Weather Squadron. We're currently T-minus 1 hour, 21 minutes, 45 seconds and counting from the current T0 for the Falcon Heavy rocket supporting the NASA and NOAA GOES-U mission. This particular weather satellite is the fourth and final in the GOES-R series, a critical tool for meteorologists around the country. We are preparing for another live interview in the next couple of minutes, so be sure to hit that like button as we're about to get started with that. Allows more folks to find our live coverage. In the meantime, we had the opportunity to talk with a lot of folks in the run-up to this mission. Very appreciative for their time. Want to bring you part of one of our interviews with a representative of NOAA. For those unfamiliar, that is the National Oceanic and Atmospheric Administration. We had the opportunity to speak with Dr. Michael Morgan. He's the Assistant Secretary of Commerce for Environmental Observation and Prediction. Here's part of our conversation. Gives you a good sort of overview, if you will, a Reader's Digest snapshot of the GOES-U spacecraft and its importance to the overall NOAA mission.
What's been most important and what we've learned over the last, the series of the previous 3 launches has been the success of the GOES mission. The GOES instruments provide information not only about terrestrial weather, but one of the important aspects of this is we're adding a new component to it which helps us with our space weather forecasting as well. So it's both terrestrial, Earth-based weather, as well as space weather. And these have improved our ability to detect fires at the ground. We have the capabilities right now to be able to detect a fire the size of a small barn from orbit, which I think is just really incredible. We have the lightning detection system, that's the GLM, the GOES lightning mapper, which is a geostationary lightning mapper, which allows us to see flashes in space, from space, which can allow us to detect where, particularly in dry conditions, fires might actually start. We can detect the smoke from those fires and see how it propagates, how it moves around the surface of the Earth, impacting air quality in rural as well as urban areas. So it's been a wonderful series of missions with the prior GOES. This next one has this additional component, which is called the compact coronagraph. This is a system, telescope, that allows us to sort of blot out the solar disk and see the corona, be able to image the corona of the sun, which allows us to detect what are called coronal mass ejections. These are big surges of magnetic field as well as plasma from the sun's upper atmosphere, possibly toward the Earth, so we can understand where these surges are directed, these coronal mass ejections are directed, which then influences ultimately space weather if they're directed toward Earth. We can actually see the auroras that we saw back in May of this year when we had some strong geomagnetic storms. These are detectable from the growing instances occurring on the surface of the sun and as they propagate through space. So it's about improving our space weather prediction, it's about improving our terrestrial prediction, looking at severe storms.
Welcome back. You're watching our live coverage here on Spaceflight Now's YouTube channel. Currently T-minus 1 hour, 14 minutes, 30 seconds and some change before the planned launch of the GOES-U satellite built by Lockheed Martin. And fortunately, we're very lucky to be joined by a member of the Lockheed Martin team. This is Dylan Powell. He is the strategy lead for weather and earth science, and he helped get the GOES-R program off the ground for Lockheed Martin. Dylan, it's good to have you with us.
Great to be here. Absolutely. Really excited about the launch.
Absolutely, and so are we. Just keeping an eye on that detached anvil cloud and the
Right.
nonsense it's getting up to. But want to talk about your time with the program and sort of getting the ball rolling, being a part of that team. When you were starting to form the idea and meet the requirements that NASA and NOAA had set out for the GOES-R series, what was that like? Walk us through the thinking behind it, the instrumentation that was built in.
Mm-hmm. Yeah, so I started all the way back in 2005 on the GOES-R proposal as a straight out of actually Goddard as an atmospheric scientist, and so I was part of the ground team for Lockheed Martin's proposal that interacted with the space team, but my focus was on the science, the algorithms, the data products, and really what the real focus for that team, because we had never flown a GOES satellite before. It was the first time Lockheed Martin had bid our A2100 commercial bus for a mission like GOES, and so we really had to focus on designing a spacecraft that could accommodate the instruments. These instruments are very complex, very sensitive. They have to have the right thermal environment, the right mechanical environment, and stability. The spacecraft has to point so that these instruments can do their scanning and collect the data they need to. So we really focused on instrument accommodation and integration for our solution, and we were lucky enough to be awarded 16 years ago, and now we're back here for the last of the satellites to be launched in that series, and we're really excited about it.
And as you were crafting that proposal and sort of laying the groundwork, how much did the prior GOES satellites sort of play into your thinking, and what was the process of trying to move that ball forward and build it out to what it is today?
Yeah, so this GOES-R series and their RSTU today is launching U was a real step function in capability for NOAA with the Advanced Baseline Imager instrument from the previous series of GOES satellites. So there really was a lot of change that needed to happen to the way the spacecraft operates, particularly the stability and pointing of the spacecraft. And so that was really the biggest challenge, was just accommodating that new instrument, that fantastic instrument that brings us all those great pictures of tropical storms and weather events. So that was really the focus. And with the GOES satellite, it's also not just an Earth weather satellite, it's a space weather satellite. In fact, it flies more space weather instruments than Earth instruments. And so that was another aspect. We have a sun pointing platform out on the yoke of the solar panel that actually points at the sun. And so integrating all those instruments onto that sun pointing platform was a real challenge. And especially with GOES-U, we've added a new instrument, NOAA's C-Core instrument, a compact coronagraph, that will allow us to image the coronal ring of the sun, looking for these disastrous CMEs that can impact technology here on Earth. So that's it's been an exciting run, and I think with GOES-U and the on-ramp of the C-Core instrument, it's a great example of on-ramping new technology, not even in the middle of the program, for the last satellite and the changes that come with that. The team just did a phenomenal job with their NASA partners, with NOAA, to be able to accommodate that new instrument that the satellite was never designed to host.
Right, and given the prominence that solar activity is having right now in the United States, given all the solar flares that we've seen, the aurora that made its way down to all 50 states, do you think that's helping the conversation and sort of spark the imagination of folks that we're watching that phenomenon, and now we're looking at coverage like this and thinking of oh well, with that capability on orbit, I could do this, that, or the other thing.
Yeah, I hope so. I hope it's, I think I know a lot of friends of mine were talking about auroras, and I live in Maryland where we don't have auroras. So
we don't do it in Florida either.
Right. And so I think that event was an eye opener for a lot of people to understand that the solar weather can really impact life here on Earth. And you know, NOAA has taken, is really the only operational agency for space weather in the world today. They have created their new space weather observations organization that's going to focus on the new architecture for space weather. GOES-U is part of that. The C-Core instrument, the compact coronagraph, is really filling the gap that the NASA SOHO instrument provides data for us today, and that's 25 years old. So we really need this observation, along with SWIFO L1 is going to launch. That's a spacecraft that'll be 1 million miles away between the Earth and Sun. That will also have a C-Core instrument. So NOAA is building out an operational architecture to give us early warnings of the solar activity so that we can respond.
Yeah, I think one of the folks in a prior briefing described it as a stereoscopic view of the sun, which is something that doesn't currently exist, and they're really excited to have, you know, on orbit. You know, before we let you go, speaking of looking down the road, you're involved in the next generation of satellites. This is the end of the GOES series, but GeoXO is the next follow-on. Talk to us about, you know, Lockheed just got awarded the contract for that. So how were you thinking about crafting that proposal and, you know, bringing the instrumentation needed to, you know, further advance from where we are right now?
We're just overjoyed that we were fortunate enough to be selected as the follow-on spacecraft provider for GeoXO. GeoXO is the geostationary extended observations. So NOAA is adding new instruments, a new satellite in the centrally located position between the east and west GOES satellites. They're going to fly a hyperspectral infrared sounder, which will provide near real-time atmospheric vertical temperature and moisture, which really impacts these hyper-local weather models. So we'll be able to improve our weather forecasting with that instrument. We're also adding an air quality instrument that will scan the entire CONUS for bad air. And we all know that that's a real problem. More people die from bad air than weather every year. And then we're also adding an ocean color instrument on the east and west satellites. So all of that is actually being incorporated into our new LM2100 bus, which is basically the direct lineage to the A2100, which is GOES-U. And so that bus is now going to accommodate all this additional instrumentation. But fortunately, with the design of GOES, we've already really figured out how to point the spacecraft, how to keep it stable. And so we're taking that technology and bringing it into GeoXO so that we've got all that bought down, NRE and learning that we're going to bring forward into GeoXO and make that successful, because it's a really important now, particularly with climate change and the weather changing so rapidly and how it impacts everybody. We need these observations. And we can't wait to get those launched in 2032. So.
I was going to say, it's going to be here before you know
Yeah,
it. Dylan, thank you so much for joining us
today.
today.
I enjoyed it. Yeah, thank you.
Absolutely. And as you can see with the countdown clock behind me, we're just a little over an hour away from hopefully seeing the launch of this Falcon 9 and the finale of the GOES series of satellites. Got lots more commentary coming up, so stick around with us. We're going to throw back to some live pictures of the pad. We'll be back with more commentary right on the other side of this. Our thanks again to Dylan Powell. Again, he's the Lockheed Martin strategy lead for weather and earth science. Certainly appreciate Lockheed Martin and giving us some insight into both the GOES-U spacecraft, the GOES-R series program, and then looking forward to the future with the GeoXO constellation. Currently T-minus 1 hour, 3 minutes, 53 seconds and counting to the planned liftoff of this Falcon Heavy rocket. The GOES-U satellite up top. Currently about 10 minutes away from the point at which the SpaceX launch director will need to make a call on the start of propellant load for this mission if they are in fact ready to go and they feel like the weather is going to play ball. So before that happens, let's go ahead and step through the countdown timeline for today's Falcon Heavy mission. Again, this will be the 10th Falcon Heavy flight for SpaceX. A little bit different, of course, for a Falcon Heavy versus a Falcon 9 mission. Got 3 first stage boosters, so the fueling timeline a little bit adjusted. Again, the call for prop load nominally happens at T-minus 53 minutes. Although, as with a Falcon 9 launch, that is essentially an approximation. If they feel like they are ready before that point to go ahead and move forward with taking that poll, they can do so. It doesn't have to happen right at the 53-minute mark. But once the go-ahead is given across the board for the start of fueling, it begins at the T-minus 50-minute mark with first stage RP1 loading beginning. Again, here's a difference between a Falcon Heavy versus a Falcon 9. On a Falcon 9, we'd see RP1 or rocket-grade kerosene being loaded on both the first and the second stages simultaneously. Here we just have first stage RP1 loading to kick things off. It's followed at T-minus 45 minutes with first stage LOX load. T-minus 35 minutes will be the second stage RP1 load beginning. And then at T-minus 18 minutes and 30 seconds, second stage liquid oxygen load begins. Before that happens, we'll see the big vent from the strong back. Happens as the feed lines are being chilled prior to that second stage LOX load. Moving to a more similar timeline with the Falcon 9, the chill down of the 27 Merlin 1D engines on the Falcon Heavy gets underway at the T-minus 7-minute mark, flowing a small amount of liquid oxygen through the plumbing and turbo pumps to protect them from the risk of thermal shock and damage. T-minus 4.5 minutes, the strong back retract sequence begins. The clamp arms underneath the payload fairing will open up, and then the transporter erector, or the strong back, reclines about 1.5 degrees away from the Falcon Heavy rocket. Stays in that position until liftoff, at which point it'll pull back in a much more rapid fashion to clear the way for the vertical climb of that Falcon Heavy. In the final 60 seconds, control of the countdown is handed over from the ground sequencer to the Falcon Heavy's onboard flight computers. The propellant tanks are brought up to flight pressure. The SpaceX launch director will give their go for launch at 45 seconds out. The engine ignition sequence is initiated at T-minus 6 seconds, as opposed to T-minus 3 seconds with a Falcon 9 rocket. But all the same, if things are in good shape, we'll see a T0 liftoff of the Falcon Heavy. Again, currently targeting 5:16 p.m. Eastern, 21:16 UTC for our friends around the world, or in other words, T-minus 59 minutes and 15 seconds. In support of this launch opportunity today, the Brevard County Emergency Operations Center has activated. Taking a look now, a zoomed-in shot from the perspective of the crew access tower looking at that Falcon Heavy payload fairings. You can see the mission patch for the GOES-U satellite at the very top and center. Just beneath that, from our vantage point, you can see the NASA meatball logo, and just to its left, just out of frame, is the logo for NOAA, the other main partner on this from the federal government, the National Oceanic and Atmospheric Administration.
Launch Control, this is the launch director on count to 1. Please pause the clock and let's go ahead and push the T0 to 21:26:00 UTC.
Copy, pausing clock and changing time.
And as you heard, we have an adjustment to that T0 time. We are shifting our countdown clocks accordingly.
And we are counting down to a 21:26:00 Zulu T0.
So again, as you just heard, we have a new T0 liftoff time for the Falcon Heavy rocket, pushing back to 21:26 if you're a fan of the 24-hour clock system, or 5:26 p.m. Eastern. Currently T-minus 1 hour, 5 minutes, 41 seconds and counting. So at this point in time, the 45th Weather Squadron is forecasting a 60% chance of favorable weather at the current T0. If they do need to continue sliding into the window, though, the weather outlook does continue to deteriorate. Currently, the 45th Weather Squadron launch weather officers are taking some extra time, that additional 10 minutes or so, to gather some more data, take a closer look at the outlook, and make sure that things are in a good order in order to be able to begin fueling the Falcon Heavy rocket. We are currently at T-minus 1 hour and counting. If you're just now joining us, you are watching our live launch coverage currently in progress for Spaceflight Now, as we are counting down to the hopeful liftoff of SpaceX's 10th Falcon Heavy rocket and the 4th and final satellite in the Geostationary Operational Environmental Satellites, or GOES, R series. This is a critical dual satellite operation that is used to monitor a range of severe weather and other climatological impacts in the Western Hemisphere, specifically in the United States. GOES-U, once it launches, will head up and become GOES-19 and take over in the GOES-East position. Once on orbit and in operation, it will work alongside GOES-18, which is the primary satellite in the position on the western half of the United States, very creatively named GOES-West. As mentioned, this will be the 10th Falcon Heavy rocket to launch for SpaceX. This will also be the second time that NASA's Launch Services Program is using this particular launch vehicle. If you recall, last fall, another Falcon Heavy rocket launched NASA's Psyche spacecraft on a journey to a metal-rich asteroid of the same name. Those side boosters that were used on Psyche will be back in action one more time on this October's Europa Clipper mission, journey out to an ocean moon. That'll be coming up again in the early to mid-October timeframe is when that window opens up. I believe it's October 10th specifically. In the run-up to this mission, though, as you may have noticed, there are 3 shiny new Falcon first stage boosters on this particular flight.
To help us avoid some weather. Current new T0 will be 2126 Zulu, and based on the LWO's report, we're looking at roughly about a 30% POV during that time to help us avoid a storm cell. That being said, I'd like to go ahead and conduct the propellant load and launch readiness poll for the NASA engineering team. NASA CE.
NASA CE, go.
SMA.
SMA, go.
SMD.
SMD is go for propellant load.
NASA MIM.
NASA MIM is go for propellant load.
LSP.
LSP's go.
The NASA engineering team is ready for propellant load and launch.
And that voice you were just hearing, as if his ears were burning, was the voice of the launch director for NASA's LSP, the Launch Services Program. That is Dr. Denton Gibson. We had the opportunity to speak with him in the run-up to this mission about the fact that they are using 3 new Falcon first stage boosters on this flight. We talked to him about that, the fact that there was not a static fire ahead of this mission, the reason behind that. And then on the backside of this clip from Denton, going to hear a little bit from SpaceX's director of NASA science missions, that is Juliana Scheiman, on the thought behind expending the Falcon Heavy core and the reason behind that, some of the performance needs for this and other missions. So let's go ahead and listen in. These are part of our conversations with, again, the launch director of NASA's Launch Services Program, Dr. Denton Gibson, as well as SpaceX's director of NASA science missions, Juliana Scheiman.
Our technical teams evaluated the hardware that we'll be using on GOES-U. As you probably know, that there's 3 new boosters that we have. So prior to arrival at the launch site, the boosters went through a stage acceptance test, which is a lot more comprehensive than a static fire. And our teams, based on that, deemed a static fire not necessary in this case because all 3 boosters just went through a full-on stage ATP, which is well encompassing of a static fire. So at this point, static fire wasn't necessary.
So when you think about booster reusability, whether we're landing a booster on land or whether we're landing a booster downrange on a drone ship or whether we're expending a booster, all that choice has everything to do with how much performance the customer requires. So some missions require less performance, in which case we can preserve some of that propellant to return that vehicle to land. And in some cases, we need to provide more performance to our customer. So for Falcon Heavy, we can do a lot of different permutations, as you can imagine, with 3 cores. For example, for GOES U, the 2 side boosters are coming back to land, the center core is expended. That was the performance point that made the most sense to meet what the spacecraft needed, to meet the spacecraft requirements. For Europa Clipper, as an example, coming up for NASA, that will be a fully expendable Falcon Heavy. Turns out Europa, the moon of Jupiter, is pretty far away. And so it kind of gives you a sense of matching the performance by the rocket with what the spacecraft customer needs.
And we're currently T-minus 53 minutes, 48 seconds and counting. As I had mentioned earlier, the T-minus 53 minute point where the poll is placed on the timeline as concluding, that is not a fixed point in time. And both SpaceX and NASA LSP have agreed that they are in a good position at this juncture to begin fueling the Falcon Heavy rocket. And of course, once fueling has begun, then the T0 becomes a fixed point in time. The rest of the window essentially doesn't matter for either a Falcon 9 or a Falcon Heavy rocket. Fueling now set to begin in just about 3 minutes. Fueling starts with loading of rocket-grade kerosene or RP1 on board the 3 first-stage boosters. That'll be followed 5 minutes later by first-stage liquid oxygen load.
Falcon Heavy tanks are venting for the starboard mount load.
This is the launch director with abort instructions. For non-urgent no-go conditions, brief the CE or LD and they will approve aborting the countdown. For urgent issues affecting the safety of the operation, operators shall call hold on the countdown net. Launch control will abort the launch auto sequence immediately and proceed into the launch abort auto sequence. At T-minus 10 seconds, launch control will be hands-off and relying on automated abort criteria for the remainder of the count.
And good call-outs from Mission Control. SpaceX alongside NASA LSP are running the countdown operations primarily from the Hangar X facility. That's where Denton Gibson, the launch director for NASA LSP, is sitting alongside the SpaceX flight team. As you heard, they are ready to proceed with fueling, coming up now in less than a minute. And as standard procedure, they went through the scrub process so that everyone is on the same page with if something were to come up in the next 50 minutes and 30 seconds, what that would be. They would call hold. Now just about 20 seconds away from the start of fueling on this Falcon Heavy rocket.
The launch auto sequence has started.
And fueling has officially begun on the Falcon Heavy rocket. Again, the process with this launch vehicle starts with RP1, now just a little over a minute into that step of the fuelings. And at the T-minus 45-minute mark is when first stage liquid oxygen load will begin. Currently at T-minus 47 minutes, 33 seconds and counting. I want to thank the nearly 5,000 of you who are joining with us live this afternoon, getting ready for this Goes You mission. If you haven't already, we certainly appreciate it if you could hit that like button for us. It allows more folks to find their way into our live launch coverage. We would certainly appreciate that. Also want to thank a few folks for your support this afternoon. Psychonaut69 gifting a Spaceflight Now membership. Appreciate that, Psychonaut. To our newest member, welcome aboard. We're glad to have you with us. Be sure to thank Psychonaut in the live chat if you haven't already. Thanks to Ash Rock, marking 3 months with us as a channel member, who says, hopefully the weather stays good enough for launch. Thanks for the great coverage as always. Well, thank you for your continued support of what we do here at Spaceflight Now. It is an honor and a privilege to be able to keep everyone informed and as thoroughly updated as possible about both the launch as well as the payload on board, the reason we're all here, the reason why the rocket is launching today, hopefully. Thanks also to Cole Cunningham for a $5 super chat. Thank you, Cole, who I think speaks for many of those of us watching this launch who look outside and see what is, broadly speaking, a very lovely day when you're just talking about being out and about, you know, sans the heat that we're dealing with. But certainly a lot more factors than what we just sort of see from the ground here as the launch weather officers doing some hard work today to make sure that things are safe for both the rocket as well as its critical payload.
Stage 1, BY and NY LOX load has started.
And with that call out, liquid oxygen load on the 2 side boosters now getting underway. That's what that call out was that we just heard. We are currently T-minus 42 minutes, 58 seconds and counting. As we've mentioned, the GOES-U satellite is the fourth and final in the GOES-R series for NASA and NOAA. The previous three, all built primarily by Lockheed Martin, have flown on Atlas V rockets from the United Launch Alliance. This will be the first time that a GOES satellite is being launched aboard a Falcon vehicle. Go ahead and take a look at the process of encapsulating the spacecraft here. Taking a look at some video provided by NASA inside Astrotech, the facility where spacecraft was placed inside the payload fairings that you see right here in this video, which you can see, if you recall, back when we were talking about the payload fairings on the rocket itself. It's got those two logos for NASA and NOAA. This is the spacecraft itself, looking at the solar panels on one side, much of the instrumentation surrounding the vehicle as well. Encapsulation happened about a week and a half or so ago, a little bit longer. And unlike with the United Launch Alliance Atlas V rocket, which the payload would be integrated vertically, for a Falcon Heavy mission, same with the Falcon 9, of course, they do a horizontal integration. So in our conversations with Lockheed Martin and the deputy program manager, we were talking about some of the additional considerations that needed to be made when looking at the logistics of this 11,000-pound spacecraft and being integrated horizontally. Some of the notes, of course, having that resilience there at the base, making sure that everything had enough support and structure to it. The additional noise you're hearing is not a broken speaker. We're now able to share with you some of the sounds at the launch pad here, which you see live on your screen, as the Falcon Heavy rocket is being fueled in preparation for a flight coming up in less than 40 minutes. All the first stage boosters are being loaded, both with RP1 as well as liquid oxygen at this point. Coming up in now less than 5 minutes, the second stage RP1 loading will begin. That'll be followed at T-minus 18 minutes and 30 seconds with second stage LOX load. It has certainly been a busy start to the week for SpaceX in preparation for this mission, alongside NASA and NOAA getting ready for this. I want to go ahead and share with you a time lapse of the process of getting the rocket to the pad itself. It was a busy Monday as we saw the rollout of the Falcon Heavy rocket. We're taking a look at a time lapse video captured from our vantage point here at the press site. You can see the hangar door open there on the right hand side of your screen. Slow and steady process, of course. Want to make sure that both the rocket and its payload were remaining safe during this transportation. In fact, at the first time they were rolling the rocket out, it did emerge briefly and then go back to the hangar. SpaceX explains that the environmental system that keeps the spacecraft cool encountered an issue, and so they wanted to go back into the hangar, make sure they had all the redundancy they needed before proceeding with transporting the rocket and its payload to the pad. And it was then overnight between Monday and Tuesday when the rocket was brought into the vertical launch position you see here on your screen. That process started just a little bit after midnight this morning. About 12:20 a.m. Eastern is when that rocket started to go vertical. There's usually a pause right at that point you saw there as they continue to make sure that everything is proceeding as expected before they bring the rocket fully upright to where it now stands today, ready to launch the GOES-U satellite coming up in 37 minutes, 17 seconds. We are currently T-minus 35 minutes, 53 seconds and counting. Less than a minute now from the start of second stage RP-1 loading, or rocket-grade kerosene. As we continue on to that point, I want to thank a few more folks for your support this afternoon. Our thanks to Don Pierce with a $2 super chat. Thank you, Don. Callisti Lee, been a member now with us for 9 months. Time flies. Also one of our wonderful moderators in the live chat. Felicity says, awesome coverage as always, Will. And I'll extend that out to the rest of the Spaceflight Now team. As for the rest of us joining today, if you haven't already, please take a second to click the like button. Help us push the stream up so more people can find it easier. To that I will say, hear, hear, and we much appreciate it.
Stage 2 fuel load has started.
I heard that good call out from SpaceX that fueling on the upper stage now underway. As I mentioned, that starts with RP-1, or rocket-grade kerosene, being loaded on board the tanks on the second stage of the Falcon Heavy rocket. Also want to thank Cole Cunningham for a $5 super chat. Both he and Charles Boyer, two of our wonderful channel members. Charles with a $10 super chat. Thank you, Charles. Good to see you this afternoon. Charles says it's a good day for a cold drink. Thanks for keeping us all up to date. We're very happy to do so. And yes, to everyone who is under the heat dome that is impacting the United States, please stay hydrated, stay shaded as much as possible. Also want to welcome Shannon Lind to channel membership at the Pad Leader level. Welcome, Shannon. We're glad to have you with us. If you look near the top of the Falcon Heavy rocket, you see just above the tops of those side boosters, you see sort of dark gray band that is near the base of the Falcon Heavy second stage. It's part of the thermal protection to help keep the cryogenic propellant at the correct temperature, as this will be an especially long coast phase for this mission. It'll be about 4.5 hours, almost on the dot, before the GOES-U spacecraft is deployed. Again, this satellite will be launched into a geosynchronous transfer orbit. It will go through a series of checkouts before it ultimately heads up to the position over the eastern half of the United States. Once on orbit, it will transfer from being GOES-U to being GOES-19, and it will also, once in full operation, take the operational name of GOES-East, working with the GOES-18 satellite known as GOES-West. In the run-up to this mission, we also had the chance to talk with, among a number of folks, Pam Calderwood. She is the Deputy Program Manager of GOES-U for Lockheed Martin, who, of course, is the prime contractor on the GOES-R series of satellites. We talked about a number of things about the work between United Launch Alliance versus SpaceX, about the challenges of the mission itself, of building the spacecraft, and you can read much more of our conversation online right now at spaceflightnow.com. But want to bring you part of our conversation as it pertains to the path forward for the GOES-U satellite. So want to pick up our conversation where she's talking with us about once the spacecraft separates from the Falcon Heavy rocket, what happens next.
We are truly, as I mentioned, waiting and watching for the first solar array stage 1 deploy. And that happens about 4 3/4, launch plus 4 3/4, launch plus 5 hours. And the reason that that's so important is this spacecraft needs power to survive. If there's any issues, and so it's very important to make sure that we have a really good solar array deployment. And with that deployment, we have 5 main panels. And with this stage 1, we're then going to go through and deploy 4 of the 5. The next big item comes approximately 2 days away from launch, and that's when we kick off our liquid apogee engine burns. So SpaceX is going to take us only so far. We need to get, as you know, to geosynchronous orbit, which is 22,260 some miles. In order for us to do that, we have to have 5 separate burns over a 14-day period that will then get us into the orbit that we need to be in. And they will range, we have LAE-1 start, as I mentioned, it'll be starting 2 days after. And then the last one will be probably around the July 8th timeframe. So those are the main things that we're going to be looking for, if you can imagine, in the first 2 to 3 weeks.
And our thanks again to Pam Calderwood. Again, she's the Deputy Program Manager for Lockheed Martin in the GOES-U program. We're now less than 30 minutes from the planned liftoff of that spacecraft, GOES-U. T-minus 29 minutes, 13 seconds and counting. The next major fueling milestone coming up is at the T-minus 18 minutes and 30-second mark. That's when second stage liquid oxygen load will begin. currently at T-minus 26 minutes, 14 seconds and counting. I mentioned the next big fueling milestone will start at about T-minus 18 minutes and 30 seconds for second stage liquid oxygen load. For those who've been frequent watchers of Falcon 9 missions, you'll know that the big vent precedes second stage LOX load. That is no different for a Falcon Heavy rocket. Slightly different timing, though. Should come up right about the T-minus 22 minute 30 second mark. Want to thank the more than 10,000 of you who are joining with us live this afternoon. If you haven't already, certainly appreciate it if you hit the like button to allow some more folks to find this live coverage as we continue to roll merrily along towards the planned T0 liftoff of the Falcon Heavy coming up at T-minus 25 minutes, 16 seconds and counting. We're now at T-minus 22 minutes, 25 seconds and counting. You can see the big vent is now underway. Now currently T-minus 20 minutes, 44 seconds and counting. Just about 2 minutes away from second stage LOX load beginning.
Stage 2, fuel load complete.
That call from SpaceX. They have concluded loading RP-1 rocket-grade kerosene on board the second stage of the Falcon Heavy rocket.
Stage 2, LOX load has started.
And as you heard from that call out, second stage LOX load has now begun, coming up just about in line with the conclusion of that big vent. Currently T-minus 17 minutes, 14 seconds and counting. We're continuing to keep our eyes very closely on the weather and that march of clouds that you can see creeping its way on over to Florida's Space Coast. The presence of anvil clouds was something that meteorologists with the 45th Weather Squadron were watching closely as they were coming into this launch opportunity today. And that continues to be the case. Looking at views of the cloud actually from the current GOES East satellite. The one that will be replaced in service, primary service, by GOES U once it's able to launch and be certified and all the checkouts are complete. So we're looking back in the opposite direction from where most of our cameras are pointed. You can see the presence of anvil cloud making its way eastward, what you just saw in the satellite imagery. We're now approaching the 16-minute mark before planned liftoff of the Falcon Heavy rocket. Of course, the weather team, the meteorologists with the 45th Weather Squadron, working very hard to make their real-time assessments of this, and of course, the rest of the full weather picture to see if they're in a good position to launch the Falcon Heavy rocket with the GOES-U satellite. Of course, one of the things that they are tracking is not only the presence of lightning itself, but the rocket's ability to generate its own lightning. And with an anvil, or certainly a detached anvil cloud that still holds a charge from the thunderstorm that produced it, that could be very bad for the launch vehicle. And so that's something that they are continuing to track as we progress closer and closer to the planned liftoff of this vehicle. Now currently T-minus 14 minutes, 46 seconds, and counting. We apologize for that sudden outburst. There is a very excited crowd gathered over at the Banana Creek viewing site near the Apollo Center. Part of the Kennedy Space Center Visitor Complex. Very neat building if you have the opportunity to visit KSCVC, where you can see a full Saturn V rocket end to end, as well as a lot of great exhibits commemorating the history of the Apollo program. All those Saturn V rockets launching from this pad that we're hoping to see a Falcon Heavy lift off from, 39A. Currently T-minus 12 minutes, 30 seconds and counting. As we are coming into our final minutes of the count, we've talked about the timeline of the spacecraft once it separates from the Falcon Heavy rocket, a bit about the Falcon Heavy itself. Let's dig a little deeper into the instruments that are on board the GOES-U spacecraft. Some of them facing the Earth, some of them facing towards the sun and out into space, both, or I should say all 7 of which, act in concert to help improve life and the safety of us here on Earth. So want to go to another one of our conversations with a member of the Lockheed Martin team to learn a little bit more about the instruments that are on board the GOES-U spacecraft.
Hi, my name is Alana Nepomuceno, and I'm the Senior Manager for the Integration and Test Group that integrated and tested the GOES-U satellite. We have a model of that here, so I'm just going to kind of walk through some of the cool features on here. This is the magnetometer. This is a boom that deploys when the satellite gets out on orbit. It deploys out about 28 feet, so not quite to scale, or not quite the right size here. Up here on the top of the vehicle, this black platform is called our EPP. That's our Earth pointing platform. So this top side of the satellite is what points back to Earth. This is our ABI, the baseline imager, and then GLM, our lightning mapper. So those are what's looking back to see weather down on the Earth. Over here on the back side, you can see this little box. This is called SICE. So that's our suite of sensors. This is the antenna wing assembly, which helps us to get data to and from the satellite. And then over here is the big solar array wing assembly, as well as the SPP. So the SPP is the sun pointing platform. So that has multiple instruments on it that look out at the sun out in space and look for space weather. And then the solar array itself obviously is what provides power when we're out there on orbit. And then maybe some other cool things to look at. Down here, this is the LAE, the liquid apogee engine. That helps us to get, once we drop off the rocket out in space, this helps us to get out to our final orbit in geostationary. And then we have some smaller thrusters around the vehicle, some 5-pounders here on the bottom, and then some smaller LTRs, which help us for station keeping and just small positioning when we're out there on orbit throughout the life of the vehicle.
And these are, I'm guessing, propellant tanks here, these golden tubes?
Right, yeah, propellant tanks here on the side, and then you also have one buried in the center of the vehicle there that you can't see.
And about how long did it take to bring the spacecraft together once you really started working on it?
It's probably 2 to 3 years to integrate the whole vehicle once it gets, at this assembly level. That's the part that my team does, yeah. It takes quite a while to run it through all its paces. We have to obviously integrate it and then do a bunch of testing, put it through all the environments that it's going to see during launch, and then all the environments that it'll see out in space as well, and just confirm that it's definitely going to work and meet those mission life requirements for the customer.
And our thanks again to Alana for spending part of the day yesterday talking with us about the GOES-U spacecraft that she and many others at Lockheed Martin helped bring together. Currently T-minus 8 minutes, 45 seconds and counting. Coming up, our next fueling milestone will be the chill down of the 27 Falcon Heavy first stage Merlin 1D engines. It's coming up now in a minute and a half, the T-minus 7 minute mark.
Stage 1, fuel load complete.
And with that call out, all three
Spacecraft is on internal power.
All three boosters on the Falcon Heavy first stage are now full up with all the RP-1 or rocket grade kerosene they need. As we continue to track the weather here, now 8 minutes out from the planned liftoff, want to keep an eye not just in front of us, but also, of course, behind us. Those clouds that we were and are watching continue to linger around here at the Space Coast. But unfortunately, they are pushing eastward. Something that the 45th Weather Squadron meteorologists are undoubtedly also keeping a very close eye on and discussing the possible
Positive Y, fuel load complete.
impacts.
Negative Y, fuel load complete.
Currently at T-minus 5 minutes, 58 seconds and counting. We are approaching the start of the strong back retract sequence. But before we hit that mark, First off, I want to thank the now more than 27,000 of you who are joining with us live this afternoon. If you haven't already, we'd certainly appreciate it if you could hit that like button for us to bring in some more folks into our live coverage, as we are now just 5.5 minutes away from the planned liftoff of the Falcon Heavy rocket. In anticipation of that, let's go ahead and take a look at where this Falcon Heavy is going to fly once it leaves Launch Complex 39A. Falcon Heavy is a dynamic song and dance of rocketry, so once it leaves the pad, of course this is a satellite heading to a geosynchronous transfer orbit, so it's going to be heading basically due east once it leaves the pad here. But the two side boosters, they're not landing on drone ships, they're going to be performing a flip maneuver that boosts back burn.
Falcon Heavy tanks are pressurizing for strong back retract.
And will land back at Cape Canaveral Space Force Station at landing zones 1 and 2. So for those who are in the Central Florida area and especially in the vicinity of Florida Space Coast, heads up because the sonic booms are loud and they will catch you off guard if you're not ready for them.
Strong back lower has started.
And with that call out, SpaceX now proceeding into the strong back retract sequence. Starts with the clamp arms underneath the payload fairings opening up, and then that transporter erector, which you can see the top of just to the right of those payload fairings, will recline about 1.5 degrees away from the Falcon Heavy rocket. Stays in that position until liftoff, which point it pulls back in a much more rapid fashion.
NLM, it's the LD on the NLM net with a final status check.
LD, everything's looking good on our end.
Copy that. Thank you.
And as you heard, another check-in with the launch director for NASA LSP, Denton Gibson.
LD,
NY lock
this is NLM on countdown 1.
LD.
NASA is go for launch.
Copy. Thank you.
And that's one important check mark
PY lock load complete.
before the planned liftoff of this Falcon Heavy rocket. Denton Gibson, as the launch director for LSP, has given his go for launch, representing the NASA side of the equation. SpaceX launch director will give their go for launch coming up at T-minus 45 seconds out. We're now less than 3 minutes from the planned launch of this Falcon Heavy rocket, getting ready to send up the GOES-U satellite on behalf of NASA and NOAA. This will be the 10th Falcon Heavy to launch to date.
Stage 1 lock load complete.
And we are very close to the conclusion of propellant load on the Falcon Heavy rocket, now just about 2.5 minutes before liftoff.
Stage 2 lock load complete.
And with that call, the Falcon Heavy is now fully fueled and raring to go. We certainly appreciate you being with us for the duration of this launch countdown, as we are now less than 2 minutes away from liftoff of this Falcon Heavy rocket. Promise we'll come back to the live chat on the other side of liftoff, but for now, let's go ahead and continue to keep our focus on the Falcon Heavy rocket and the remainder of the count.
Ground gas closeouts.
As you heard and you see with that venting, we have reached the ground gas closeout stage. Now minute 20 before planned liftoff. One minute.
Falcon Heavy is in startup.
SpaceX Launch Director, go for launch.
And with that, the SpaceX Launch Director has given their go for launch, adding to NASA's green light. We are now just a little more than 30 seconds away from the liftoff of the 10th Falcon Heavy rocket.
T-minus 30 seconds.
20 seconds. 15 seconds. And here we go in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition and liftoff of the Falcon Heavy rocket on the NASA NOAA GOES-U mission. Falcon Heavy has cleared the tower, and the fourth and final GOES satellite is on its way to geostationary orbit. Merlin 1D engines. Falcon now traveling faster than the speed of sound, passing through max Q, the point of greatest aerodynamic pressure on the vehicle. Some great tracking views from our Adam Bernstein here. Now a minute 30 into flight, seeing the rocket from the vantage point of our friend Pete Carstens with Max Q Productions. We're coming up on a few different events in rapid succession. At T plus 2 minutes and 25 seconds, the side booster engines will cut off for BECO. They will separate 3 seconds later. Then the side booster boost back burn begins at T plus 2 minutes and 44 seconds. That boost back burn concluding at T plus 3 minutes and 53 seconds. Finally, first stage main engine cutoff for MECO just before the 4-minute mark at T plus 3 minutes 56 seconds. Stage separation just before the 4-minute mark. And then the start of the Merlin vacuum engine on the upper stage at T plus 4 minutes and 6 seconds. Now coming up on BECO. And there you see BECO. Booster separation.
Side booster separation confirmed.
And a great
VAC
vantage point from the Falcon Heavy onboard cameras. And my goodness.
TYNY boost back startup.
There's the start of that boost back burn as seen by Pete Carson's tracking camera. Those two side boosters will be making their way back towards landing zones 1 and 2 at Cape Canaveral Space Force Station. And again, if you are in Central Florida,
all vehicles are following nominal trajectories.
Be prepared for the sonic boom as those boosters are making their way back through the atmosphere. Now a little more than 3 minutes into flight. This boost back burn has less than a minute to go. Continuing with some great tracking from Pete here. We're now just a few seconds away from the conclusion of that boost back burn.
boost back shutdown. TY boost back shutdown. MECO. Stage separation confirmed. And back ignition.
All good callouts, all good events from SpaceX here. That Merlin vacuum engine now powering the upper stage as the first stage side boosters continue their trajectory.
All vehicles continue to follow nominal trajectories.
Nominally.
Bearing separation confirmed.
Heard from SpaceX. Coming up, the next event as we cross the 5-minute mark, and this flight is coming up at T plus 6 minutes and 36 seconds. The side booster entry burn will begin. The burn lasting about 15 seconds. Still keeping close tabs on these boosters as they make their way back towards Florida's Space Coast. Those pulses that you're seeing there on the side boosters, those are the cold gas thrusters helping to adjust the attitude of the side boosters, making sure they're following the correct trajectory as they make their way back towards
Stage 1 FTS is saved.
LZ1 and LZ2. The center booster that you saw powering the rocket, that was the last to separate from the second stage, that will be expended on this mission. Now a little more than 6 minutes into flight. Less than 30 seconds now on the start of that first stage entry burn on the side boosters. How about 10 seconds?
CYNY entry burn startup.
You see a good start of that entry burn by all accounts. These boosters flying for the first time, and
PYNY entry burn shut down.
Certainly earning
PYNY FTS is saved.
Earning their stripes with this mission. Now a little more than 7 minutes to flight.
All vehicles continue to follow nominal trajectories.
A good call from SpaceX as we're coming up on the start of the landing burn. Coming up less than a minute. It'll start at approximately T plus 7 minutes and 53 seconds.
PYNY transonic.
Stage 2 FTS is saved.
You can see those hypersonic grid fins also helping to provide some stability and steering for those side boosters. Coming up on the start of their landing burn.
PYNY landing burn. Stage 2 is in terminal guidance. PYNY landing light deploy. PYNY landing confirmed. Go.
And with a little bit of
orbit insertion.
Extra zhuzh from the sonic boom of those boosters coming back down. 2 side boosters on the Falcon Heavy rocket have safely made their way back down to landing zones 1 and 2 for the very first time. May have been a little hard to pick up, but after the booms coming down in succession, you may have heard a little noise. That is the reverberation of that sonic boom bouncing off the metal at the VAB and pinging its way back towards our ears and our microphone. So a nice little accent of being able to capture the sonic boom sounds as we're sitting here at the press site. And we're fortunate to be able to bring those sounds and sights to you live. We are currently T plus 10 minutes, 56 seconds and counting. As we mentioned, this is not a short jaunt for the GOES-U satellite to head up to its geo orbit. I want to bring you to where we currently are with this mission, looking at the launch timeline now that the rocket has lifted off and it is now being, well, has been powered by the second stage, that Merlin vacuum engine, currently in a coast phase. As you see here with the telemetry data on the right-hand side of your screen, following that track. The Merlin vacuum engine will reignite for the start of its second burn at T plus 26 minutes and 19 seconds. That burn lasting a little bit more than a minute, concluding at T plus 27 minutes and 46 seconds. And then it goes into an exceedingly long coast phase before that second stage engine reignites at T plus 4 hours, 21 minutes, 18 seconds. That third and final burn of the upper stage before satellite deployment wraps up. T plus 4 hours, 21 minutes, 51 seconds and counting. And then finally, the fourth and final GOES-U satellite will be deployed. T plus 4 hours, 30 minutes and 2 seconds. For those of you who may not have been with us before when we talked about it and introduced you to Pam Calderwood, I want to go back to part of our interview since it highlights what happens next with the GOES-U satellite once it finishes this very long coast process and prepares for spacecraft separation. So again, here is part of our conversation with Pam Calderwood, the Deputy Program Manager for GOES-U from the prime contractor for this spacecraft, Lockheed Martin.
We are truly, as I mentioned, waiting and watching for the first solar up array stage 1 deploy. And that happens about 4 3/4, launch plus 4 3/4, launch plus 5 hours. And the reason that that's so important is this spacecraft needs power to survive if there's any issues, and so it's very important to make sure that we have a really good solar array deployment. And with that deployment, we have 5 main panels. And with this stage 1, we're then going to go through and deploy 4 of the 5. The next big item comes approximately 2 days away from launch, and that's when we kick off our liquid apogee engine burns. So SpaceX is going to take us only so far We need to get, as you know, to geosynchronous orbit, which is 22,260 some miles. In order for us to do that, we have to have 5 separate burns over a 14-day period that will then get us into the orbit that we need to be in. And they will range. We have LAE1 start, as I mentioned, it'll be starting 2 days after. And then the last one will be probably around the July 8th timeframe. So those are the main things that we're going to be looking for, if you can imagine, in the first 2 to 3 weeks.
So certainly no rest for the weary as GOES-U begins its journey in a little more than 4 hours from now, once it separates from the Falcon Heavy rocket. That second stage. Want to bring in the voice of one more person here, but before I do, want to thank some of the other voices who have been active in our live chat, have been supporting us throughout this live launch coverage. It's been a wonderful day as we were sort of on pins and needles watching the weather to see if it was going to play ball, and in fact, it fortunately did. I want to thank Mrs. Ed3 for a $10 super chat. Thank you, Mrs. Ed, who's also been a channel member for 2 months and says we are her favorite YouTube channel. It's very kind of you. Much appreciated. Thanks to channel member Adam, not to be confused with our launch photographer Adam, the $10 super chat saying, let's celebrate this amazing achievement in space exploration and discovery by the SpaceX team. Go Navy, fly Navy. Our thanks as well to another channel member, Greg Jazz Jr. with a $5 super chat, who's sending greetings from Middleburg. Clearly this message coming before the liftoff saying, let's hope the weather cooperates, and thankfully it did. Addicted to Decibels with a $5 super chat says they are sitting on the other side of the Indian River watching and hopefully enjoyed the show. Christy Riley with a $5 super chat, one of our wonderful channel members. Thank you, Christy. Ed Cordero with a $10 super chat as well. Thank you, Ed. Says great broadcast as always. Thanks. Thank you for your support, Ed. Ruth Laurel with a $2 super chat saying, way to go, Spring Hill, Florida. Will, I love your voice. Well, thank you, Ruth. Appreciate the kind words. Trinity, a.k.a. Mama T, upgraded her channel membership to the Mission Specialist level. Appreciate that added vote of confidence, Trinity. Thank you for your ongoing support. Our thanks as well to Christopher Brummett with a $7.70 Canadian super chat with a quote that I sadly don't know the reference to, saying, what's the weather like, Ollie? Space weather. Folks in the live chat, chime in and let me know where that comes from, because I unfortunately apparently have something I need to watch later on. A greetings and a $10 super chat from my mom from the California coast. So everyone say hello to Mary Robinson in the live chat. Jonathan McD, marking 4 months as a channel member at the Power Leader level with a hashtag send it. And finally, last but not least, certainly, SG joining us this afternoon with a $10 super chat. Thank you, SG. Well, once on orbit, again, the GOES-U satellite will be renamed as GOES-19, and it will be positioned and taking over the spot of GOES-East as the primary satellite in that orbital position, working alongside GOES-18, otherwise known as GOES-West, to provide robust coverage of the full continental United States and the Western Hemisphere. The primary instrument on all these GOES satellites is one that has evolved over time and is going to continue evolving as the prime contractors on this particular scientific instrument, called the Advanced Baseline Imager, or ABI, progresses. Manufactured by L3 Harris, based actually right here on the Space Coast down in Melbourne. We had the opportunity to talk with one of the program leads, so let's go ahead and listen in and learn a little bit more about the primary objectives on this iteration of the ABI and what's coming around the corner with the GeoXO version of satellites, first one launching in 2032.
The ABI stands for the Advanced Baseline Imager, and L3 Harris has designed and built that at our Fort Wayne, Indiana facility. And what the ABI does is it scans the Earth every 10 minutes across 16 channels or 16 color bands from the visible bands to the infrared bands. And then that data is sent back down to Earth to our GOES-R enterprise ground system, where that data is actually processed into products that are sent out to forecasters that are used for predicting severe weather and monitoring environmental disasters. The majority of the subsystems that we use on the ABI are being reused on GXI or GeoXO Imager. What we are doing is we'll be upgrading the electronics. We'll also be adding 2 additional bands to the GXI. So there'll be 2 spectral bands that will be added for low-level water vapor, and then there are 7 of the older bands, the previous bands, that will get increased resolution. So most importantly, in the visible bands, we're going down to 250 meter resolution, which is going to really enhance and sharpen the pictures of the weather that we're seeing and the cloud formation and the oceans and everything else that the ABI observes.
And that currently T plus 22 minutes, 40 seconds and counting. Certainly a celebratory mood here at NASA's Kennedy Space Center as this mission is off to the races, but still quite a bit of work left to take place before most folks get to breathe a sigh of relief. As mentioned, GOES-U deployment doesn't happen until T plus 4 hours, 30 minutes, and 2 seconds. And then there's still quite a bit of work, as we heard from Pam Calderwood, managing the process of the deployment of the solar panels. 4 out of 5 of those panels will deploy so they can start powering up the batteries on the GOES-U spacecraft. We are coming up on the burn of the second stage, SES-2. That's T plus 26 minutes and 19 seconds. That burn lasting just about a minute and a half in total. Now T plus 26 minutes, 24 seconds and counting. You see that second stage burn now getting underway. Again, this burn lasting a little more than a minute, concluding at T plus 27 minutes and 46 seconds. That second stage and burn continuing on for about another 30 seconds. See the telemetry track there as the upper stage of the Falcon Heavy rocket now making its way over the coast of Africa. Approaching it, we've got the onboard cameras back. This burn has less than 10 seconds remaining.
Nominal transfer orbit.
Good call out for that transfer orbit. At this point, the Falcon Heavy second stage is going to be on a very, very long coast phase. That Merlin vacuum engine won't reignite until T plus 4 hours, 21 minutes and 18 seconds for a burn lasting a little less than 30 seconds. That'll set up the GOES-U satellite to deploy at T plus 4 hours, 30 minutes and 2 seconds. Taking a look at the live chat, want to thank a few more folks for their support this afternoon. I'm Lita with a $5 super chat. Thank you so much, Lita. Who says, hi, Will, team, mods, and Spacefly Now family from Lita and granddaughter. KM with a $5 super chat as well. Thank you, KM, for your support. Mel Roberts Herald checking in from Chicagoland and appreciates learning something new on this mission. It's always wonderful. Never stop learning, and you'll always enjoy life. Finally, Sharon Walker with a $2 super chat. Really appreciate that support, Sharon. And with that, here's what we're going to do, folks. As mentioned, it is going to be some time before the deployment of the GOES-U spacecraft, and we're going to continue to keep tabs on it. But we're going to move our coverage from this dedicated stream over to our 24-hour live stream over on Launchpad Live. So for those who would like to continue tracking the progress of the Falcon Heavy upper stage and anticipation of the deployment of the GOES-U spacecraft, again, it is currently just about 5:56 here on the East Coast. So here locally, we're looking at a deployment right about 9:56 p.m. Eastern. So again, we will continue our live coverage and move this tracking map over to Launchpad Live, which actually it's currently there right now. And we'll continue to update you through there as well as on our social channels with further developments on this mission. as we conclude things, want to thank the team that has made today possible. First off, big ups to our wonderful moderators, Callistia Lee and Astro Jen, for holding it down in the live chat. Really appreciate the both of you helping us out today. And a broad and general thanks to Stephanie B., Astro Joe, and Rusty Shackelford for the times when they're able to lend a hand as well. Want to thank our friend Pete Karstens with Max Q Productions for some stellar rocket tracking today, as well as our launch photographers, Adam Bernstein and Michael Kane, who, in addition to Adam doing his own great tracking, is doing some launch photography as well. Set out some remote cameras to capture the moment, and we'll be sure to post that on our social channels. And if you're not already following the fellas, you can find Adam and Michael on X. Michael's at MD Kane Jr., Adam Bernstein at ABurnNYC. And while you're over there, be sure to give Spaceflight Now a follow simply at Spaceflight Now. We're also on Facebook and Threads for those who do not have X. And on your way out the digital door, be sure to click subscribe right here, as we are inching ever closer to 250,000 subscribers, and we certainly appreciate all of you and your vote of confidence and your support with our reporting and live launch coverage. Our thanks to, of course, our Spacefly Now editor, Stephen Young, for running the technical operations of the broadcast today. Most importantly, our thanks to you for wherever you are watching from around the world. For all of us here at Spaceflight Now, I'm Will Robinson Smith. One more reminder, you can continue following this mission over on Launchpad Live. Live views of the pads, as well as, of course, the live telemetry information and the track from NASA and SpaceX in anticipation of the deployment of the GOES-U satellite coming up just before 10 o'clock Eastern. T plus 4 hours, 30 minutes, and 2 seconds. And as always, folks, be good to yourselves, be good to others, and we will see you next time. Bye-bye.